Hi everyone, we're going to solve the differential equation. F prime of x equals 2 divided by x cubed minus x. And the way we do this, we're going to integrate both sides. So you're basically going to integrate f prime of x and also integrate this side. And for this, real quick, this is x times x squared minus 1, which equals x times x plus 1 times x minus 1, using your difference of squares there. And then put the dx here. So basically your right-hand side, or your left-hand side, sorry, this is just going to equal f. So that part's done. We're just going to keep calling this f. This is the part we need to work on, the right-hand side. We're going to use partial fraction decomposition. So we're going to use, we have 3 repeated linear factors. So we have a divided by x plus b divided by x plus 1 plus c divided by x minus 1 equals 2 divided by x times x plus 1 times x minus 1. Now we're going to clear the fractions by multiplying through by our least common denominator, which is x times x plus 1 times x minus 1. So we multiply this by this first term. The one that goes away is the x. So we're still left with that. So you have a times x plus 1 times x minus 1. When you multiply the b, the x plus 1 goes away. So we're going to have bx times x minus 1. And then when you multiply the c, this one goes away. So that's going to be cx times x plus 1. And when you multiply this one, these two just cancel. So you just get equals 2. Now let's let x equal 1. If x is 1, then both of these go away. They all are going to be 0. And you're going to get 2c equals 2. Therefore, c equals 1. If you let x equal negative 1, let's see, which ones are going to go away? These two will go away. So you're going to get your b, and you're going to have 2b equals 2. Therefore, b equals 1. And finally, let's let x equal 0. And that means these two will go away. And you're going to get negative a equals 2. So a equals negative 2. So there's your ABCs. And then all we're going to do is, again, we already have the left-hand side is f. And we're going to rewrite our function here as decomposed. So let's do that. We're going to write this as f equals the integral of negative 2 divided by x plus 1 divided by x plus 1. I'm just filling in my a, b's, and c's. All right. Now, from here, we're going to integrate. So we have f equals, and if you want, we can write it f of x. Be more precise. So this is going to be negative 2 times ln of absolute value of x plus ln of absolute value of x plus 1 plus ln of absolute value of x minus 1 plus c. And the next step is just to move this 2 using your power property of logs. So that's going to give you negative ln. And once you do that, you can take away the absolute value because this is a even power. And then the rest we're just copying down. So I'll do that very quickly. All right. And now we're going to condense it to a single log. So my f of x equals, now if there's a pot, we're going to write it just one log. I'm just going to write a log there, ln, natural log. So if it has positive, that means they go in the numerator. If it's negative, it means it goes in the denominator. So basically, I can combine these two by multiplying these two. And remember, this is going to be x plus 1 times x minus 1 equals x squared minus 1. So I can just write this as absolute value of x squared minus 1. And I can just put this in the denominator, so that's x squared. Put little parentheses there, plus c. And this is going to be your final answer. Thank you. Have a nice day. Bye-bye.